When you think of foam, a number of things come to mind. All are created by chemical reactions. For a group of materials experts at NASA's Langley Research Center, it means something else. They invented a high-tech polyimide foam called teak for new spacecraft.
The original first-generation foam was developed because of the next-generation launch technology, the reusable launch vehicle, the next space shuttle. They had a need, at the time they were looking at reusable cryogenic fuel tanks, so they needed a higher temperature foam.
Meanwhile, a small firm called PolyuMAC Inc. in Hialeah, Florida, was searching for a specific type of foam for one of their customers. After researching possible candidates, one of their experts, Miguel Vasquez, contacted the Langley team to learn more about the foam and get some samples. Because teak showed possibilities for the firm's customers, PolyuMAC decided to license it.
Not only do we have technologies that support our missions, NASA's mission, but also these technologies are used to develop new products and processes that benefit industries within the U.S. and worldwide.
The foam wasn't exactly the right density, and the process to produce large quantities was expensive. So the Langley researchers and Vasquez decided to collaborate on modifying it.
That foam was very good for what it was, for high densities. But we were looking something for lower densities and easier, friendly to manage and to manufacture on a facility like ours.
By changing teak's chemistry, the team invented a new generation of the foam, one that could be manufactured at a lower cost and one with a lower density. Langley and PolyuMAC jointly patented a new version called FPF-44.
This foam is unique in that it's a low-density, flexible foam, and you can tailor the properties of it. So you can do some mechanical compressions on the foam after it's been cut into whatever shape you want.
Since it's flexible, doesn't burn, and produces little or no smoke when exposed to fire, FPF-44 is an ideal insulating material. PolyuMAC has now also designed and built the equipment to produce and cure FPF-44 in large quantities, and currently they're manufacturing the foam to be used as insulation on naval ships. To test the foam as a candidate for ice mitigation on the Space Shuttle external tank, a NASA team simulated shuttle launch conditions. For the test, the Langley PolyuMAC team designed and fabricated forms of FPF-44 to insulate a gap that has icing issues on the external fuel tank.
We thermoformed it to the shape, and then we learned that we're changing the properties of the foam through these compression cycles or thermoforming cycles.
The successful test means that the foam could be a candidate solution for ice mitigation issues on the current space shuttle, as well as insulation on future space vehicles. As the team continues to collaborate, they're working on reducing the foam's density even more. In addition to marine applications, the reduced density FPF-44 version could be used as insulation on aircraft.
Properties are much better than a fiberglass, but we need to be at a very low density because weight is very sensitive in an airplane. That's why we're really looking for, to being able to drop density and being able to manufacture in a bigger scale, bigger blocks, so we can supply the demand.
If you can get the properties right so you can be as good or better than fiberglass that's currently used, I mean, the sky's the limit as far as putting it on aircraft, inside aircraft.
Ships, airplanes. Who knows where you might find FPF-44 in the future?